Arithmetic sequence. Our learning target for this video, I can find the nth term of an arithmetic sequence. So first, what is an arithmetic sequence? So arithmetic sequence, it is also known as an arithmetic progression. And aside from that, arithmetic sequence, it is a sequence whose consecutive terms have a common difference. So again, I just would like to emphasize, it's a sequence whose consecutive terms have a common difference. So here, the sequence a sub 1, a sub 2, a sub 3, and so on, up to a sub n, is arithmetic if there is a number d such that second term minus first term equals d, third term minus second term equals d, fourth term minus third term equals d, and so on. The number d is the common difference in an arithmetic sequence. So this is the general term of a sequence. So a sub n equals a sub 1 plus n minus 1 times d. So you take note, this will be the general formula you are going to use in solving arithmetic sequence. So first, let us identify each term mentioned in the formula or in the general term of a sequence. So a sub n, this is considered the nth term. A sub 1, this means first term. So n, this refers to number of terms. And lastly, d refers to common difference. So I'd like you to take note that in solving problems involving arithmetic sequence, guys, you need to sort necessary data such as first term, number of terms, and common difference, so that you would know, you will be able to find out what is the value of particular term or a sub n. So you need to identify the first term, the number of terms, and then the common difference. If one of those three necessary data is missing, then therefore you need to look first the value for that particular data before you proceed with finding the nth term. Okay, so for now, let us solve first for the nth term of the given sequence. Last time, we discussed about finding the nth term or the general term or the explicit formula of the given sequence with very lengthy steps, so such as preparing table, finding the difference, forming equations, finding the values of the variables, and then substituting again in the general form, and then checking, and so on. So here, since we do have our formula already for arithmetic sequence, we can now use that to also find the nth term of the given sequence, provided that it is an arithmetic sequence. So for that, let's have example. So here we have 15, 18, 21, 24, 27. So first step is we need to get necessary data for our formula afterwards. So we do have a sub 1 or the first term, and we do have d or the common difference. So let's identify that using the sequence given. So our a sub 1 is 15, and our common difference, so we're going to subtract second term by first term, third term by second term, fourth term by third term, we will have 3. Okay, and our general term for arithmetic sequence, we have a sub n equals a sub 1 plus quantity n minus 1 times d. Okay, so based there in our given sequence, our a sub 1 is 15, then our d equals 3. So moving on, substituting in our general term for arithmetic sequence. So substituting a sub 1, which is 15, and d equals 3. And then simplify. As you can see, we do have here a sub n equals 15 plus n minus 1 times 3. So here, applying the PEMDAS rule, we need to simplify first the n minus 1 quantity, 3, or times 3. So with that, we are going to have distributive property of equality. So we will have 3 times n, 3n. 3 times negative 1, we will have negative 3. And then, we can now combine like terms. As you can see, we do have constant 15 as well as constant negative 3. So we are supposed to combine those. And we will end up with 15 plus negative 3 will have positive 12. And we are supposed to write first the term with the variable following the proper way of writing an expression based on the degree of each term. So 3n must be written first before the constant. So 3n plus 12. But maybe if you will ask me, Miss, can I have an answer 12 plus 3n? So maybe I'll not accept, though the value is still the same, but still the proper way of writing that is based on the degree of each term. So 3n must be the first term and 12 follows. So that's it. It means our final answer is the general term for this given sequence is 3n plus 12. Okay, next practice exercise. I'd like you to find the nth term of the given sequence. You may pause the video for a while and then you resume watching if you want to check your answer already. Okay, so of course our step 1 always is sort out the necessary data. So we have a sub 1, and for d, so we have 9, and for d we have negative 6. And then of course you need to be familiar with the general term of an arithmetic sequence, which is a sub n equals a sub 1 plus quantity n minus 1 times d. Then, of course, we are supposed to substitute already. So, a sub 1 is 9, d is negative 6, and then same process, you will have distributive property. So, 6 times n, 6n, negative 6n, by the way. And then negative 1 times negative 6, it's positive 6. And then combining like terms, we will have positive 15, and then negative 6n must be written first. So therefore, our final answer is a sub n equals negative 6n plus 15. Okay, so next practice exercise, we have the sequence. I'd like you to find the general term or the nth term of the sequence. Okay, our answer for this is 5n plus 10. Okay, moving on, what if we are asked to find the 12th term of the arithmetic sequence 15, 20, 25, 30? So you are supposed to find out the value of the 12th term of the sequence. So, first step, of course, you need to sort out the necessary data. But in this case, since you are supposed to find out already the 12th term, that means you need to have this basic data for the formula later on. So, you need the first term, you need the value of n, and the common difference. So for a sub 1, based on the sequence given here, so we have 15. And then for our n, since you are supposed to find out the 12th term, then that means your n is 12. And lastly, for the d, for the common difference, you just subtract second term by first term, third term by second term, fourth term by third term, and so on. So as you can see, we can have 5 there. And of course, our formula, so you need to really be familiar with this. So a sub n equals a sub 1 plus quantity n minus 1 times d. Since we do have our formula already, you just simply substitute the data that we sorted out. So substituting, then simplifying using PEMDAS. You need to simplify first the ones with or inside the parentheses. So 12 minus 1, it's 11. Then 11 times 5 is 55. And lastly, 55 plus 15 do have 70. So therefore, our final answer is the 12th term of the arithmetic sequence is 70. Okay, for your practice or exercise, find the 10th term of this given arithmetic sequence. So here's the solution for your practice exercise. So sort the necessary data, a sub 1, n, and then d. So we have a sub 1 is 12. N is, since you are supposed to find out the 10th term, that means number of terms will be 10 as well. And common difference, you just simply subtract second term by first term. So 7. So if you're going to check third term minus second term, it is still 7, and 33 minus 26, it is still 7. So moving on in our formula, so substituting the data that we sorted out. So here it goes. So we have to simplify this. So the ones inside the parentheses, so 10 minus 1, it's 9. Then 9 times 7, 63. Then last step would be combine the 12 and then 63, both constant. So 12 plus 63, we have 75. Therefore, our final answer would be the 10th term of the given arithmetic sequence is 75. Okay, next. In the given arithmetic sequence, which term is 197? In this case, the value of a particular term is already given, but your task is to find out which term is this. Do you think it's the 10th term, it's the 15th term, or it's the 20th term? So let's find out. Okay, so first, you need to sort out the necessary data. So we have a sub n equals 197. It was given in our problem already. Okay, next we have our first term, or a sub 1, we have 8. And then for our common difference, we have 7. So again, how did we get the common difference? We just simply subtract second term by first term, or third term by second term, fourth term by third term, and so on. Okay, so moving on to our formula. So we have here, and then substitute, of course, the data that we got coming from the problem. So here, and then let's apply distributive properties. So following the PEMDAS rule, we need to simplify first those terms or operation inside the parentheses. So that means 7 times n, 7n, and 7 times negative 1, negative 7. And then, looking at the right side of the equation, we do have like terms here. We have positive 8 and negative 7, so we need to combine those two. So we'll have positive 1. And as you can see, we can also combine the constants, which are 197 and 1. So applying the APE, so you are more particular with transpose, so we will transpose negative 1 to the left side. Therefore, combining negative 1 with 197, we do have this, but this is not yet our final answer. We are supposed to divide both sides by 7 to isolate the n. Therefore, dividing both sides by 7, we will have n equals 28. So our final answer would be in an arithmetic sequence given, so 197 is the 28th term. Next, we have find the 20th term of the arithmetic sequence whose first term is negative 6 and whose 7th term is 24. Okay, so for now, we need to set aside first our purpose of getting the 20th term. Instead, we need to complete first all the necessary data for the formula. And as you can see, here in our problem, we do have a sub 1 as well as we do have a sub 7. Therefore, we can say that we also have the value for n as of now. So I'd like you to focus first with the first term given, with the 7th term given, and of course the n. So getting the data coming from the problem, so we have negative 6, 24, and since we are going to assume that the last term is 7th term, so for now let's have n equals 7 so that we can get the value of d, because a while ago I mentioned we do have necessary data, 3 basic data that we need. So we have first term, n, and then d. So you can see we don't have d yet, so we need to look for d by using the given data here. So we have our formula, then substituting the given data that we sorted out here, and then PEMDAS rule, so we process first inside the parenthesis 7 minus 1, so it's 6, then multiplied with d, so it is 6d. Then combining like terms, so we'll have 24 plus 6, so 30. Then it's not yet the final answer. We need to isolate the d by dividing both sides by 6. Therefore, our final answer will be d equals 5. Now, since we do have all the necessary data already, we do have the a sub 1, n, which is 20 because we are supposed to find that 20th term. And since we do have the d already, therefore, we can now get the 20th term. Substituting in the formula once more, so here, so process those inside the parentheses first, the 20 minus 1, which is 19, and then multiply with 5, we do have 95, and lastly combine it with negative 6, therefore a sub 20 equals 89. That's it. So our final answer would be this one. The 20th term is 89. Okay, next practice exercise. I'd like you to answer this on your own, then pause the video, and if you're done answering, you may now resume watching the video to check your answer. Okay, so based on the given problem, so our data there, we do have a sub 5, we do have n as well, and we do have common difference. So based on the problem, our a sub 5 is negative 10, and since the, the maximum term mentioned in the problem is 5, so therefore we are supposed to assume that the last term is 5 for now, and then the common difference is negative 6. As you can see, our necessary data is not yet complete. We do have n, we do have d, but our a sub 1 is missing. Therefore, you are supposed to find out the a sub 1 first. So substituting in the formula, so we have here, so we have to simplify those inside the parenthesis of 5 minus 1, we have 4, and then multiply 4 with negative 6, you do have negative 24. And now you need to combine like terms. As you can see, we do have negative 10 and negative 24, so we need to combine those constants. So we have negative 10 plus 24. So I know you are particular with the shortcut wherein in applying APE, you are particular with transpose, the shortcut one. So negative 10 plus 24. And then simplifying, negative 10 plus 24 is 14. So therefore, our a sub 1 is 14. Next, since as you can see, we do have our a sub 1 already, which is 14. And since you are tasked to find out the 30th term, therefore, your n will be 30 already. And for the d, same, we do have negative 6. Okay, so substituting the data in the formula, so here it is, and then simplify those inside the parenthesis, which is 30 minus 1, so we have 29, and then multiply with negative 6, so it's negative 174, and then lastly you combine it with 14, so a sub 30 is equal to negative 160. So therefore, your final answer will be in the arithmetic sequence whose fifth term is negative 10 and whose common difference is negative 6. The 30th term is negative 160. Okay, so here's your additional practice exercise. So you may pause the video first, then if you're done answering the 3 questions, resume the video, and there you can see if, or you can check if your answers are correct. So here's the answer for number 1. So we have the general term or the nth term is a sub n equals 10n. For number 2, a sub 50 or the 50th term is 351. And for number 3, n equals 25, therefore, the 25th term is what you are looking for. So that's it. So thank you so much for watching this video. I hope you learned about finding the nth term of an arithmetic sequence. And thank you so much. So I do hope you subscribe in this channel so that you will be updated of the upcoming playback videos. Thank you.